Number 2 is a histogram. So that is going to require me to draw a graph. So a graph first. And I'm going to mark, let's see. Okay, what's the lowest number in here? 74.7. Okay, and then what's the highest number? 82.5? 82.7. Okay, so I probably made this way too big now, but that's okay because it's erasable pen. Why my erasable pen is not erasing? That is unsatisfying. But I'm not good at patience. Okay, so first of all, good morning. Second of all, I really hate the not gonna lie movement that's happening right now. With everyone saying not gonna lie or I'm gonna be honest. I really hate it. I hate it a lot. I have a lot of hate for it. How come? Because if they have to say that, that implies that every single other thing that they've ever said to you is a lie. Well, I'm not a liar. Then you wouldn't have to say, I gotta be honest. So, yep. Okay, so, but I gotta be honest, I don't know what this histogram looks like. Usually I know the answers to these problems before we do them. This time I don't. I don't actually know if the axis is tall enough. Um, so it's going to be a minor adventure. Anyway, I do know that whenever you do a histogram, the y-axis should have a label of frequency, and the x-axis should also have a label. I have no room because for some reason I chose to do all of the work for number 3 shoved up here when there was all this space down below. I don't know why I did that, but that's fine. It's okay. We're moving on with life. So, um, okay, histogram, super easy. I want to remind you that this, when I say 74 to 75, I really mean 74 to 74.9. So I'm going to say to you guys, how many numbers are in the 74s? Okay, so looking up at this data set, how many numbers are in the 74s? One. Okay. And how many numbers are in the 75s? 0. And how many numbers are in the 76s? 0. And how many numbers are in the 77s? 0. And how many numbers are in the 78s? 2. So I make that bar 2. Okay, how many numbers are in the 79? 2. Okay, how many numbers are in the 80s? I think this is the one that might get me. 1, 2, 3, 4, 5. Oh, hey, it's fine. If anything, I could have scooched this graph up and not made it so tall. It's all good. It's fine. We're fine. Everything's fine. Okay, how many are in the 81s? 1, 2, 3. And how many are in the 82s? 1, 2, 3, 4. And that's it. That's how you make a histogram. Do you guys have any questions about this before we move on here? Let me leave it in for you for a minute. So the bins down here, it says 74 to 75, but you guys should know it's 74 to 74.9 in this bin, and then 75 to 75.9 in this bin, 76 to 76.9 in this bin, and so on. That's really the one thing about histograms. Okay, now let's do number 4. Flip your page over. And this is a box and whisker plot again. So we're going to start by putting them in least to greatest. I see the least. That's easy. Okay, do we think I did it correctly? Okay. So how many numbers are there? 17? Okay, so if there's 17 numbers, then the middle number is going to be the median. So that would be the 9th number. So there's 8 on each side. Okay, so the median is 18. Okay, if you hear me say nothing else in this problem, when you find the first quartile, you don't use the median. It's everything below the median. Okay, so how many numbers are there? 8. So it's going to be in between 14 and 15. The minimum's 4. First quartile is going to be 14.5. Median is 18. Okay, and then when you find the third quartile, same thing. You don't use the median. So median's gone now, and it's going to be between these two. And the average of those is 40. Does that make sense to everybody? Oh no, my ruler slipped. Okay, so I made marks at 4, 14.5, 18, 40, and 55. And remember, those are not going to be perfect. It's okay. And the box is the middle 3, and then the whiskers go to the outside. Okay, today's work is actually on a resource page. There is nothing in the notebook today. So if you could please find the resource page for number 5, 6, and 7. And keep that ruler. You're probably going to want that ruler still. Okay. A researcher suspected that some blood types are more susceptible to the DAPT genetic defect than other blood types. The researchers collected the following data to investigate. Make a conditional relative frequency table to determine whether there is an association between blood type and the presence of the DAPT defect. All the two-way tables in this lesson are displayed for convenience with the variable across the top as the independent variable. That means you calculate percents for columns. The percents in the column should add up to 100%. Okay. Now, first thing I want to talk about is, do you guys know about the 4 blood types? Have you talked about that before in other classes? Okay, so people have different blood types. These are the 4. If you're looking for a B, O type of blood. I don't actually know what type I am. I can't remember. But these, by the way, are not percents. Let me say that again. These numbers are not percents. You're like, yeah, they're decimals. No, I mean, like, they're actually counts. And the reason is because this says the number of people in millions. So we're very excited that this is a very small number of people that have the DAPT defect. Having this is a bad thing, I'm assuming. So the smaller, the better. Okay, the first thing I'm going to ask you guys to do is add up the columns for the total. So on your calculator, 0.3 plus 0.28 plus 0.07 plus 0.03. You might be able to do that in your head. 0.68. 131 plus 137 plus 31 plus 12. 311. Even though I'm doing this with the ruler, it's still coming out wonky, but that's okay. Okay, now hopefully you have a calculator handy. You're going to need a calculator. So if you don't have one, grab one right now. And I'm going to get you guys started on the first box. And then I want you to work in your groups to get the rest of the boxes. I'm going to use my Post-it note trick here. I'm going to cover this up. Okay, and this column says to get the conditional relative frequency here, I take 0.30 divided by 0.68. So it's this box, this top left box over the total. So 0.3 divided by 0.68 is 0.44. Do you guys understand what to do for this table? Okay, do you know what this side will be? Yep, beautiful. Okay, so just keep working on your own to fill the table in. Okay, now did you guys get a little teeny tiny difference in the two percentages for A? Should you be concerned about that? No. Here's the hard part about stats. It's something I have to teach everybody in stats. Stats is very different from math in the fact that it's like you're dealing with actual real people and real circumstances and stuff, that things don't come out perfect. Terrible. If you're a person who likes x equals 3, then stats might not be for you. Because there's a lot of gray areas. This column actually adds up to 0.99, I believe. Which is really unsatisfying. But you gotta just kind of let that go. It's okay. It's just because we round it. So don't worry about it. But if you get really close to 100% in the column, that's good enough for me. So just to check your math, this should add up to 1.00. This should add up to 1.00, but it doesn't. It's super close though, so it's okay. Okay, so now we actually have to answer the question. So we made the conditional relative frequency table, and now we have to determine whether there is an association between blood type and the presence of the DAPT defect. Does the blood type change whether or not you have DAPT? No. Okay, that problem is done. Flip over to number 6 when you're ready. Do you want me to explain why there's no association? You sure? Okay. You do? Oh, okay. So these people have type O blood. There's a 44% chance that they have DAPT, and there's a 44% chance that they don't have it. So it doesn't matter if you have type O blood, like you have 44% chance of having it. If you have type A blood, there's a 41% chance you have it and a 42% chance you don't have it. So what you're doing is you're comparing these across. And if those are really, really similar to each other, they don't have to be perfect because it's stats. But if they're really, really similar to each other, that means that the probability doesn't change. Now, let me contrast that with the next one. So I'm hoping the next one will make it make more sense. Okay. According to the US Census Bureau, of the 312.59 million people living in the US in 2011, the number of people living alone is given in the two-way table below in millions. Okay. So we have a lot of questions that we need to answer from this table. What is the probability of living alone? Okay, great. So you went to 32.73 because that's the total number of people living alone. But remember, probability is what you're looking for over the total. What's the total in this problem? Yes, great. Okay. What is the probability of being 65 or over? So these are all of the people 65 to 74. These are the people 75 or over. Both of those columns count, correct? You have to add them. Great job. So 21.4 plus 17.76. And make sure when you do this on the calculator, you do it in 2 steps. Add the top first. And then divide. Okay, are there any questions about A or B before I move on? Do the two numbers that I got here make sense? Yes, honey. That's what I was going to do. Okay, so for C, notice that these two are the opposites of each other. 65 or over is the opposite of being under 65. So we're going to do what's called the complement. We're going to take 100% minus this. Do you have to do it that way? No. I could add up all 5 of these numbers and divide it by 312.59. That's totally fine too. That would be 100% credit, no big deal. But if you see that these are opposites or complements, you could just subtract it from 100%. Okay, now, what is the probability of being 35 years of age and living alone? this is where I'm gonna start shading in my table. So hopefully you guys have a pencil. If you're using a pen, you can just like circle numbers instead. What numbers in the boxes are 30 under 35 years of age and living alone? There's two numbers. Perfect. So these are the two boxes where both of these conditions are being satisfied. 35 years of age or under and living alone. So 1.45 plus 4.16. Okay, last one in number 6. To find the probability of being 35 years of age or living alone, Kui added the total number of people in the first two columns to the total number of people in the first row. What did Kui do wrong? Okay, so what they're saying is he added, I actually don't know what gender Kui would be. They added this number plus this number and this number. That's what this problem is saying. That Kui added these two and that one to get or. What did he do wrong? Kui, as in French, yes. What? You have an idea? Anyone have an idea? Let me help. Okay, there's my assistants for my visual people. Why can't you just add the totals of the two columns and add the total of the first row together? Take a look at my shade.
Because, well, 1.05 and 4.16, both separate criteria.
Yes,
Under 25 and living alone.
correct. So the problem with it is if you just add the totals together, you're counting those boxes twice because they're in both totals. So you have options. You can just either add up all of the shaded boxes, or you can add the totals and then subtract off of the ones that are double shaded, because the double shaded ones are the ones that are counted twice. I think that's more sophisticated, so that's probably what I would do. So let's show our work down here. So this is what I mean. So you can take your totals. So your totals are 111.12 plus 41.57 plus 32.73. But you can't leave it like that because you're counting these two boxes twice. So you have to subtract 1.45 plus 4.16. I'm just gonna put qui. I don't. What I need to know, much more important than the math here, is if there is a squishmallow named qui. Okay, last one. Notice what I made. See, there's seven. That's why there's seven. It's bad. Mine is so bad. Please do not judge me on the even spacing of these boxes. It is not good. Oh, true. Thirty-five to 44. Okay, the question is, do you guys know what to do to fill in this table? Are you sure? We just did it on the previous one. Okay. So first column, what would I divide? Yeah, it's a real mystery for you. You're really stuck. Okay, now real quick. You guys understand where I got that from? This box. Are you completely clear about where I got those two numbers from? Okay, now in this particular case, there's only two rows. So you could just put 0.99 here. You don't have to do the figure out the fraction and do the math. You could just subtract from one. That bottom row has to be the complement. It has to be everything else. So what I'm saying is save yourself a lot of time and money on your car insurance. Just kidding. Just a lot of time. And just say, oh, well, if this is 0.01, that has to be 0.99 because Mrs. Talbot told me these need to add up to 100%. Are you guys with me? Okay, so work on your own to fill in the rest of the table. I'm going to do the same. Trying to use your super good friends to make you like it. I like you. This is a 30.55. We have the same stuff so far? Okay. How'd we do? Okay, so now I need to answer the question. So I want you to look across and notice that as a person is getting older, they have a much higher probability of living alone. So notice these decimals are changing as the people are getting older. This always makes me so sad. I don't know why. And then notice that the probabilities are also changing for not living alone, which makes sense. So the question is there an association between age and whether or not you live alone?
Yes.
Yes, definitely. You're much more likely to live alone if you are older. That's it. So you're gonna say yes. You are much more likely to live alone if you are older, which is sad. Mhm. Just hold on. Almost didn't put a period at the end of my sentence. Okay. So, can you guys look at the stamp sheet side, please, real quick when you're ready? Okay, so as of this moment, you should have this is in your notebook. You should have this homework done, and this is in your packet. This is tonight's homework, 17 through 23, skip 22. I'm gonna stamp as many people as possible, but I might not make it all the way around. That's okay.